Hey folks, welcome back to the channel where we take the wildest science and engineering concepts and break them down so even your cat could understand. Today we're tackling the biggest energy mystery out there, the holy grail of clean power, nuclear fusion. The question on everyone's minds, are we finally getting closer to infinite energy or are we just chasing a scientific unicorn? Now, before we get into the nitty-gritty, let's clear something up. Nuclear fusion is not the same as nuclear fission. Fusion is the cool, responsible sibling, while fission is the one who throws wild parties and leaves a mess. Cough. Chernobyl cough. Fission splits atoms apart, releasing energy, but also giving us a bunch of radioactive waste and the occasional meltdown. Fusion, on the other hand, is all about bringing atoms together. It's the ultimate chemistry matchmaker. Here's the deal. Fusion is what powers the sun. Yeah, that giant ball of plasma in the sky that gives us sunburns. It's been fusing hydrogen atoms together for billions of years. When hydrogen nuclei, protons, for the science geeks out there, fuse, they create helium and release a ton of energy in the process. The sun does this all day, every day, and it makes it look easy. But here's where things get tricky. Trying to recreate the conditions of the sun here on Earth is like trying to fit a camel through the eye of a needle while it's on fire. To get fusion going, you need insanely high temperatures like 100 million degrees Celsius. That's about 6 times hotter than the core of the sun, by the way. And you thought it was hot when your AC broke last summer. So why is everyone so obsessed with fusion? 2 words, clean energy. Unlike fission, fusion doesn't produce long-lived radioactive waste. It doesn't come with the same risk of meltdowns or explosions. And the fuel, just some hydrogen isotopes like deuterium, which we can extract from seawater. So basically, we have an endless supply of fuel, no radioactive mess, and enough power to keep our phones charged forever. It's the energy dream. Let's fast forward to today. Are we finally close to achieving this? Well, it depends on who you ask. First, there's the ITER project in France. No, not like the guy who directs traffic. ITER stands for International Thermonuclear Experimental Reactor. It's a $22 billion project that's been under construction for, only a few decades. They're trying to build the world's largest tokamak, which is this donut-shaped machine that uses magnets to contain super-hot plasma, like a futuristic nuclear Krispy Kreme. The goal of ITR is to produce more energy from fusion than it takes to get the reaction started. Right now, all the fusion experiments we've ever done on Earth have required way more energy to start the fusion reaction than they actually produce. It's like lighting a bonfire and then spending twice as much money buying matches. ITR wants to flip that script and finally break even, or even better, generate more energy than we put in. Sounds simple, right? Except that managing a 100 million degree plasma in a magnetic field is a bit more challenging than frying an egg. But wait, there's more. The US has its own project, NIF, the National Ignition Facility. Their method is even more dramatic. They blast tiny hydrogen targets with lasers, trying to force the atoms to fuse. That's right, fusion powered by lasers. It's like something out of a sci-fi movie. Last year, NIF announced a breakthrough where they produced more energy than they put in for a brief moment, like a spark before a fire. Sure, it was small, but in the fusion world, that's huge. It's the scientific equivalent of running a marathon and then realizing you only need to shave off 26 miles to finish. Now I know what you're thinking. Okay, cool, but when can I expect my fusion-powered smartphone? Hold your horses, because we're not there just yet. Even though we've seen some breakthroughs, fusion is still incredibly difficult to maintain. We can get a fusion reaction to start, but keeping it going without collapsing is like trying to balance a porcupine on a beach ball. We're still a couple of decades away from having a commercial fusion reactor. At least that's the optimistic estimate. But what happens if... Scratch that, let's rephrase that. What happens when we do crack the code on fusion energy? What kind of world would we be living in? First up, electricity would become cheap, like really cheap. Imagine getting your electric bill and instead of feeling the sting, you laugh and throw a pizza party. That's because fusion uses an incredibly abundant fuel, hydrogen. And once you've got the reactors built, the energy they produce is practically limitless. No more fossil fuels, no more pollution from burning coal, oil or gas. The era of paying too much for energy would be over forever. Next, carbon emissions would plummet. Since fusion doesn't rely on burning anything, it doesn't pump carbon dioxide into the atmosphere. This would be a game changer in the fight against climate change. Instead of trying to invent carbon capture technology to mop up our mess, we'd just stop making the mess in the first place. Hello, clean skies! No more wildfires, no more melting glaciers, no more polar bears looking sad in those nature documentaries. Fusion would be the knight in shining armor that the planet has been waiting for. But that's not all. Fusion could power space exploration. Because fusion is such a dense and efficient energy source, it's perfect for powering spacecraft. With fusion reactors, we could build spaceships capable of traveling to Mars, Jupiter, or even beyond the solar system. Forget the Mars colony. How about a Neptune colony? The dream of interstellar travel would go from maybe someday to, hey, pack your bags, we're headed for Saturn's rings next summer. And speaking of societal impacts, fusion could finally bring electricity to every corner of the globe. Over 1 billion people still don't have reliable access to electricity, and fusion could change that. With reactors that don't rely on specific weather conditions, yes, I'm looking at you both, solar and wind, or finite resources, fusion could provide clean, stable power to the entire planet. We're talking schools with lights, hospitals with life-saving equipment, homes that are warm in winter and cool in summer, all powered by a never-ending source of energy. Now, I'm not saying it'll be all sunshine and rainbows. Building fusion reactors is going to take a massive investment of time, money, and political will. The infrastructure costs will be huge. Plus, we'll need to figure out how to safely handle the massive magnetic fields, not to mention the need for materials that can withstand temperatures hotter than the sun's surface. But hey, no biggie. We've done crazier things before, like landing people on the moon or creating deep-fried butter at the state fair. So, what's the verdict? Are we close to infinite energy? Well, we're definitely closer than we've ever been before. Between ITER, NIF, and other global fusion projects, the pieces of the puzzle are slowly falling into place. But like all good things, it'll take time. We're probably looking at a few more decades before we see fusion energy lighting up our cities. But when it does, it's going to be revolutionary. A fusion-powered future means cleaner air, cheaper electricity, and a shot at solving the climate crisis. In the meantime, keep your fingers crossed, invest in some solar panels, because they're pretty great too, and maybe build a fusion reactor in your garage, just for fun. But seriously, don't do that. It's probably illegal and definitely dangerous. Thanks for tuning in, folks. If you enjoyed learning about how we're inching closer to becoming a fusion-powered planet, don't forget to smash that like button and subscribe. We've got more mind-bending, world-changing engineering content coming your way. Stay curious, and as always, keep fusing those brain cells.